So we're looking at our water properties lab, and we're looking at our first station called Do They Mix? And so we're looking at these jars of oil and colored water. So as we look at each jar, we notice that we see kind of a clear liquid on top, and then we see our colored liquid on the bottom. And we notice that these two layers are starting to settle out. We can see a little bit here where it's sticking a little bit to the jar. As we look at these, we notice that on the bottom, we've got our water, and on the top, we've got our oil. And as we look at why these will mix but not stay mixed, we know that water has a positive charge and a negative charge. Because of that, we say that water is polar. Polarity is this idea that you have a positive charge on one side and a negative charge on the other. It's kind of like if we look at our Earth, we've got the North Pole and the South Pole. And a magnet will point to that charge. It'll point to that charged North Pole, that magnetic north. If we were to shake one of these jars, we notice that we can get these substances to mix temporarily, but then they start to settle right back out as soon as we leave the jar. So the dark color on the bottom, that's our water, and the light color on top, that's our oil. Because the food coloring is in the water, but not in the oil, then that lets us know that the food coloring must be polar because it's staying mixed with the water. So polar and polar will stay mixed together, but polar and non-polar will not. All right, then as we look at our next one, we notice that the oil is above the water. And that's because water has a density of 1 gram per cubic centimeter. And so since water has a density of 1, that's our standard, and the oil is lighter than the water, it's floating on top, then we know that the oil has to have a density of less than 1. All right.